So the problem is expand the function x square y plus 3y minus 2 in the powers of x minus 1 and y plus 2 using Taylor's theorem, Taylor's theorem or Taylor series, considering up to third degree function. That means you should continue up to the x minus 1 whole cube, y plus 2 whole cube. That terms should be existing. Okay. So write the solution for this. So before going for the solution, I think yesterday I have taken, I need to write the standard formula for the series expansion of two variables, right? So as I'm mentioning that if you are not able to get it directly, you can rewrite from the Taylor series expansion, which is available for single variable, is being converted into the two variable problem. So what I mean that, but in the examination you are not supposed to write the Taylor series expansion with single variable. So directly you need to write the two variable case. So we can write it that by the Taylor's theorem up to third degree term, the Taylor series expansion is considered is f of x comma y can be written as, so by the formula I can write it is f of a comma b plus, so the first term I can write x minus a, f minus a, and it is a dou f by dou x is calculated at a comma b plus y minus b into dou f by dou y calculated at a comma b. This is the first term. So actually you should write 1 by 1 factor, but okay, it's only 1. Plus I'm writing plus 1 by 2 factorial into, so I need to write the expansion of the square term. So that I can write it as x minus a whole square into dou square f by dou x square. Please remember this formula. For everything we are writing this formula initially. So into a square, a plus b whole square, right? So it's a square term, 2 into x minus a into y minus b into dou square f by dou x dou y. So one with respect to x, one with respect to y. Plus, so b square term and like, what is b square? So it is a y minus b whole square into dou square f by dou y square. And please remember this is calculated at a comma b. So and this is also calculated a comma b. So this is my second term. So sorry, it is my third term. Then the fourth term is containing the cubic terms. So what I do now, because I'll be having comparatively more terms, I'm starting my term over there. So 1 by 3 factorial into, I can write x minus a whole cube into dou f by dou x, dou f by dou x, dou cube f by dou x cube. So 3 times with respect to x, calculated at a comma b. Plus, so what's the formula for a plus b whole cube? A cube plus 3a square b. Okay, I can write 3 into x minus a whole square into y minus b whole power 1. It's a dou cube f by, I need to take 2 times with respect to x, 1 time with respect to y, and please compute at a comma b. Plus 3 into x minus a into y minus b whole square into dou cube f by dou x cube. Sorry, dou cube x by. So with 1 time with respect to x, 2 times with respect to y is evaluated at a comma b. Plus the last term is containing the b cube term. So that is a y minus b whole cube into dou cube f by dou y cube calculated at a comma b. So this is my fourth term containing the cubic terms. If you want to get it fourth term, yes, you can able to write it. Okay, but this is not there in the, because up to the third degree it is asked. Okay, suppose I'm asking that in the examination up to fourth degree term, then you need to write plus 1 by 4 factorial. So then I need to write the expansion for the a plus b whole power 4. What is a plus b whole power 4? I can write over there for the reference. For the reference, I can write here something like, so a plus b whole power 4. So the standard formula I'm writing, 4c0 is 1, a power 4, b power 0, plus 4c1 is 4 into a cube into b, plus 4c2. So the coefficients are 4c0, 4c1, 4c2, 4c3, 4c4. So these are the 5 terms you can get it. So 4c0 is 1, 4c1 is 4, 4c2 is equal to 4 into 3 by 1 into 2. So it becomes 6. 4c3 is a 4c1, that is 4. This is 1. So these coefficients I need to write there. So that is 6 into a square b square plus 4 into a into b cube plus b power 4. So this is the expansion now. If you want to write for 5th degree, but generally in the examination it won't ask. But if it is asked for 5th degree, then you need to write a plus b whole power 5. So a plus b whole power 5. So what it comes now? I need to write 5c0, 5c1, 5c2, 5c3, 5c4, and 5c5. So this is equal to 5c1, 5c5, which is equal to 1. 5c1 is equal to 5c4, which is equal to 5. 5c2 is equal to 5c3, which is equal to 5 into 4 by 1 into 2. So it becomes 10. 5 into 4 by 1 into 2. So it becomes, it becomes 10. That becomes 10. So these coefficients will be coming as a power 5 plus 5 into a power 4b plus 10 into a power cube b square plus, what's the next term? Next term will be 10 into a square b cube. The next term is 5 into a b power 4 plus b power 5. So like that you can able to expand it for any degree using the binomial theorem. Okay. So but I am stopping over here. I can write plus and so forth. That's all. Plus and so forth. Okay. Now I am using this formula. So there I need the functional values. So now now I can say taking, what is a now? A equal to, because it is in the powers of x minus 1. So x minus a. So that is a equal to 1. And b is equal to, so it is written as y plus 2, which can be written as y minus 2. So y minus b structure, b is equal to minus 2. And rewriting the same formula with a equal to 1, b equal to minus 2, I can write it. Okay. Now I need to evaluate. Sir, not getting. What I'm saying here is, see this, it is asked for up to 3rd degree. So I have written this expansion. In this one, what is the thing now? Because this I need to write in terms of x minus 1 and y plus 2. Okay, so that is called, it is x minus a is there, x minus a and y minus b. Now compare it is now. So is it not the expansion in terms of x minus a and y minus b? So the Taylor series expansion, about are in the powers of x minus a and y minus b is given by this one. So here I am talking about, it should be x minus 1. So a is equal to 1. Y minus b. So b is equal to minus 2. Now is it clear? So this is the general expansion for x is equal x minus a and y minus b structure. Is it clear? So here I am comparing now that x minus a should be x minus 1. So a is equal to 1. And it should be y minus b, it means y plus 2. y plus 2 can be written as y minus of minus 2 because I should have y minus b structure. So that b equal to minus 2. Is it okay? Yes, that's good. Thank you. Now I need to evaluate all these values. How many values I need to evaluate? How many values I need to evaluate? Let me check it now. 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10. And please remember, I'm saying that only this value is calculated at a comma b. Please remember, means after derivating the value, after derivating this function, put x equal to a and y equal to b. Don't include this term, because if you include this term, it becomes 0. This is out of the value substitution. This is clear? Now let me evaluate one by one. So given that f is equal to, given that f of x comma y is given as, let me recall, this is x square y plus 3y minus 2 if I recall correctly. Let me check it now. Yes, x square y plus 3y plus minus 2. Now let me take up what is f of 1 comma minus 2. Why? I need to write f of a comma b. So that is called 1 square into minus 2 plus 3 into minus 2 minus 2. The value is minus 10. Okay. Now therefore I can write f of 1 comma minus 2 is minus 10. I got one value. I highlighted. So first value is evaluated. This is obtained. Next, let me go to the next one. So what is dou f by dou x? So this is the dou by dou x of, I need to write x square y plus 3y minus 2. The value is with respect to x only. So x square y derivative is 2xy. 3y derivative is 0. Minus 2 is constant is 0. So this is 2xy. But I need to get the dou f by dou x at x equal to 1 comma minus 2. So what is this value? So that is 2 into x equal to 1, y equal to minus 2. The value is minus 4. Okay. So in short notation, this is f of 1 comma minus 2 is minus 10. This is fx at 1 comma minus 2 is minus 4. This is clear? I repeat. This is in short notation, the f value at 1 comma. This is called f. This is called fx. What is fx? Fx is nothing but dou f by dou x. It's a notation only, right? That's only I'm writing. Next, dou f by dou y I need to. Dou f by dou y, which is nothing but dou by dou y of x square y plus 3y minus 2, which is equal to, then which can be with respect to y, x square is a constant, y derivative is a 1, plus 3 into y derivative is a 1. So minus 0, which can be written as x square plus 3. Now let me compute dou f by dou y at 1 comma minus 2, which is equal to, now it is a 1 square plus 3, which is equal to 4. So in short notation, is the fi at 1 comma minus 2 is 4. So only 3 values are completed. Next, dou square f by dou x square, which is nothing but dou by dou x of dou f by dou x, which is nothing but dou by dou x of dou by dou x of dou f by dou x. What is dou f by dou x? Dou f by dou x is already here. So that is 2xy. So that 2xy I am writing. So which is nothing but dou f by dou x with respect to 2xy is 2y. Now which can be written as dou square f by dou x square, which is nothing but at 1 comma minus 2 can be written as 2 into minus 2, which is minus 4. Do you agree? So in short notation, this is f double x. F double x at 1 comma minus 2 is minus 4. Okay, so these are all the values I'm having. Next I need dou square f by dou y square, which is nothing but dou by dou y of. I think I need. Let me check it. In the expansion, I evaluated dou square f by dou x square, then dou square f by dou x dou y, then followed by dou by dou y square. So let me calculate. Let me calculate the other term first. Now I need dou square f by dou x dou y, which is nothing but dou by dou x of dou f by dou y, which is nothing but dou by dou x of, what is dou f by dou y? Dou f by dou y is equal to, it is x cube plus 3. So it is x cube plus 3, which is nothing but 3, sorry, this is x square plus 3, x square plus 3, which is nothing but 2x plus 0. Now I need to get that's dou square f by dou x dou y at 1 comma minus 2. At 1 comma minus 2 is 2 into 1, which is 2. 2 into 1, which is 2. Okay? So that in short notation, f x y at 1 comma minus 2 is 2. So screen is not visible. Screen is not visible. Now is it okay? Is the screen is visible now? Yes, it is visible. It is visible. Yes, yes. Thank you. Right. Now I evaluated only till now 1, 2, 3, 4, 5. Still left with me. So what I am doing now? Let me do one more point over there only, so that it will be finished here. Okay, I'll continue here. So then dou square f by dou y square is the next term. So that is dou by dou y of dou f by dou y, which is nothing but dou by dou y of dou f by dou y. What is dou f by dou y? Dou f by dou y is already x square plus 3. Now this is with respect to x we are talking, so which becomes 0. Therefore, dou square f by dou y square at 1 comma minus 2 is 0, because there is no xy term. So in short notation, f double y at 1 comma minus 2 is 0. Is 0. So finally, I got this two things. Still anything is determined? Yes, still I need to determine the, how many you need? So I have evaluated 1, 2, 3, 4, 5, 6 completed. Now I need these 4 evaluations. Now let me continue. Let me continue for the rest of the things. So then I need dou cube f by dou x cube, dou cube f by dou x square dou y. In the same order, let me evaluate. Dou cube f by dou x dou y square and dou cube f by dou y cube. So these are the 4 values I need to evaluate. Then dou by dou x of dou square f by dou x square, which is nothing but dou by dou x of, let me write those notations, dou by dou x of dou square f by dou x dou y, which is already known. Then dou by dou x of dou square f by dou y square, then dou by dou y of dou square f by dou y square. Now see that if I know these 2 values, I can copy here. This is another value, this is another value. So let me take up those previous 3 values. So dou square by dou x square is equal to 2y. Let me substitute. This is 2y. So with respect to x is 0. Then this is dou by dou x of xy. So that is 2x. This is 2x. So this value is 2. Then dou by dou x of, so with respect to y square, this is 0. So this is 0. And dou by dou y of again 0. Again 0. So now, because of 0, it is becoming 0. And please remember, it is a constant. So now I can write this f triple x at 1 comma minus 2 is 0. F at double xy at 1 comma minus 2 is 2. F x y square, or you can write x square y, anything you can write, no, makes no problem. At 1 comma minus 2 is 0. And f of y cube at f of y cube at 1 comma minus 2 is 0. Okay, now finally I got all the 10 values that I required up to the third degree term. So what I'm doing now, let me highlight these values. Minus 10, minus 4, 4, minus 10, minus 4, 4. Let me check it. Minus 10, minus 4, 4, minus 4, 2, 0, minus 4, 2, 0, followed by 0, 2, 0, 0, and that it continues. If it is also fourth degree, then the next 5 values will get it. So let me substitute in the same order in the formula that f of x comma y is equal to, that is x square y, x square y plus 3y minus 2 is equal to, now this is minus 10 plus x minus 1 into minus 4 plus y plus 2 into 1, 2, 3, 4 plus 1 by 2 factorial into x minus 1 whole square. Do you recall? X minus 1 whole square, 10 gone, minus 4, 4 gone, then into minus 4 plus 2 into x minus 1 into y plus 2 into minus 4 gone, 2 plus, yes or no, this is constant, x minus a, y minus b, x minus a whole square, this is x minus a into y plus 2, then the next thing comes as y minus y plus 2 whole square into 0 plus, so this is on this and that, plus 1 by 3 factorial into, what you say, x minus 1 whole cube into 0 plus 3 into x minus 1 whole square into y plus 2 into 2 plus 3 into x minus 1 into y plus 2 whole square into 0 plus y plus 2 whole cube into 0 plus 1 by 4 factorial into, like that it comes. Now let me simplify this. Don't expand it. So wherever the zeros are happening, let me cancel those zeros. 0, 0, 0, 0. Anything else? Now let me write down. So here this could be written as, I can write over there. So that is called x. I can write this way, right? So x square y plus 3y minus 2 is equal to, which is minus 10 plus, not plus, minus 4 into x minus 1. Don't write minus 4 inside, okay? Because my problem is to evaluate in the powers of x minus 1 by plus 2. So don't simplify further. Plus 4 into by plus 2, okay? Plus this 1 by 2 factorial is 2. So this 2 and 4 will get cancelled, which left with minus 2 into x minus 1 whole square. So this 2 and this 2 will get cancelled, 2 left with us, plus 2 into x minus 1 into y plus 2, and this is 0, and here is the 3 factorial. So 3 factorial is there. 3 factorial is 3 into 2. So here there is a 3 there is a 2 which will get cancelled, left with plus x minus 1 whole square into y plus 2 plus and so on and so forth. Because it is asked about only the third degree term, I can stop here. Is it clear? So hence this is the solution. Any doubt? Okay. So the question is because of the Taylor series or the Taylor's theorem, whatever it is, from the theorem the series will be evaluated as n tending to infinity, the remainder after n terms is tending to 0. So based upon that one we can find the series. Okay. Now let me tell you how the formula is being written now. So the f of x can be written as so the basic formula can be written as from your Lagrange's theorem, if I recall correctly. So f of a plus h is equal to f of a plus h is equal to you can write f of a plus h into f dash of a plus h squared by 2 factorial into f double dash of a plus h cube by 3 factorial into f triple dash of a. So like that it continues. Okay. So which is coming from your, I call it as a generalized mean value theorem, which is a extension to the Lagrange's mean value theorem, right? So because you are already aware with the Lagrange's mean value theorem, it is being extended further. We can get a generalized mean value theorem. We call it as a Taylor's theorem. So here what we are doing now, here I am taking that a is taken to be 0 and h is taken to be x. So with the substitution, I can get as f of 0 plus h. So f of x can be written as f of 0 plus x into f dash of 0 plus x squared by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0 plus and so on and so forth. So this we call it as a Maclaurin series. Maclaurin series. Okay. Now, the next idea it comes. So f of x is returning in terms of the. This is also called as a Taylor series expansion about 0. Okay. Now we are writing this f of x as f of I can write x plus a minus a without any effect, because a and a minus a will get cancelled. On rearrangement it can be a plus x minus a. So this is looking like the f of a plus h structure. So where the h is nothing but x minus a. Now if I'm going to imagine using this formula, I can get it as this is f of x can be written as f of a plus x minus a. So looking into the details of this expansion, so now it is about a plus h structure. It is f of a plus h can be written as x minus a into f dash of a plus x minus a whole square by 2 factorial into, I repeat, it's 2 factorial into f double dash of a plus x minus a whole cube by 3 factorial into f triple dash of a plus and so on and so forth. So this is a beautiful expansion. We call it as about x is equal to a, or we call it as in the powers of x minus a. So this is the story regarding the single variable. Now the same thing is being extended for the 2 variable now. So instead of simple x comma a, what I replace it there, I can write it something like f of a plus h comma b plus k. So now instead of f of a, you can have f of a comma b, the value at that point. Now instead of h, you can write plus instead of single derivative, but here I have 2 partial derivatives, which can be written as h into fx plus k into fy. So what is fx now? Fx is nothing but, because I'm writing the short form of this dou f by dou x, because of the space. So fx and fy representing the first order partial derivatives. Now followed by I need 1 by 2 factorial, and followed by the second order derivatives, followed by the h square. So what are the second order derivatives I have? Second order derivative is nothing but I can have f double x, f xy, and f yy. So these are the second order derivatives which are in 3 number and associated with this is, when I say it's a single, it is associated with the h square. But when I is talking about, it is associated with the h and k, and this is associated with the k square. So that I need to write it now. So I can write h square f double x plus 2h k f xy plus k square f double y. Now, in the similar way, if I am going to expand it, I need not to tell you what would be the next term. So it is 1 by 3 factorial into all the triple derivatives. Exactly, absolutely. Someone has already supplied. So that is called, now how to write it? It is h cube f triple x plus h, so plus 3h square k f double x square y plus 3h k square f x y square plus k cube into f triple y. So this is the term you are writing, plus and so on and so forth. Now the same thing is again transformed into this, taking to a equal to 0, b equal to 0, h equal to x, and k equal to y. I can write the expansion as Maclaurin series for the 2 variable cases. Now that can be written over there. Taking that, what I'm doing now, taking that a is equal to, so over here a is equal to 0, h is tending to x, and b is equal to 0, and k is tending to y, then this will become the Maclaurin series. Now, but my problem is to rewrite for this expansion. So what is this expansion? That same f of x comma y, the same f of x comma y can be written as the f of 0 comma 0 plus, this is how we are writing it as x into fx at 0 comma 0 plus y into fy at 0 comma 0 plus 1 by 2 factorial into, you can write as x square f double x is evaluated at 0 comma 0 plus 2xy into fxy at 0 comma 0 plus y square into f double y at 0 comma 0 plus and so on and so forth. Plus and so on and so forth. If you want to represent those plus and so on and so forth up to third degree, I can write over that 1 by 3 factorial into, yes, it is x cube f triple x at 0 comma 0 plus 3x square y into fx square y at 0 comma 0 plus 3xy square into fxy square at 0 comma 0 plus y cube into f triple y calculated at 0 comma 0 plus and so on and so forth. So okay, no problem. This is clear. After this, any doubt? Yeah, let me continue. So similarly, I can represent of this one. So that is f of x comma y can be written as, it is f of a plus x minus a comma b plus y minus b. So looking into this structure, you can expand it. So that is what we call it as this expansion. So let me expand it in the next slide. Using this one, I can write the f of x comma y can be written as, which is the f of a plus x minus a comma b plus y minus b. So this is in the powers of x minus a and y minus b. So that I'm writing here, this is f of a comma b plus what you write, 1 by 1 factorial into, for the sake of generalization, x minus a into fx at a comma b plus y minus b into fy at a comma b. So previously I used to write dou f by dou x at a comma b. Instead of that, I can use this expression plus 1 by 2 factorial into, yes, it is x minus a whole square. So f double x is calculated at a comma b. Now see that when I'm substituting this is only the calculated at a comma b. Plus 2x minus a into y minus b into fxy at a comma b. Plus b minus plus y minus b whole square into f double y at a comma b. Plus 1 by 3 factorial into x minus a whole cube plus what? No plus, into f triple x at a comma b plus 3x minus a whole square y minus b. So 2 times with respect to x square and y at a comma b plus 3 into x minus a into y minus b whole square fx double y. That's called fxy square I can talk. It is a comma b plus the last term y minus b whole cube into f triple y at a comma b plus if you want you can write the fourth degree also. That's up to you. Show the fourth page. So this is how we are writing. Now this is being expanded in the next page. Is it clear? So because the space is available, for the generality, let me type up the fourth is also by plus 1 by 4 factorial into how many terms you will have? In the cubic term, you will have 4 terms. In the power 4, you can have 5 terms. What are they? X minus a whole power 4 f 4x's a comma b plus 4 into x minus a whole cube into y minus b into fx cube y at a comma b. So this can be written as x power 4. It makes no difference. So 4c0, 4c1. Next 4c2. 4c2 is equal to 4 into 3 by 1 into 2. So that is 6. 6 into x minus a whole square y minus b whole square into fx square y square calculated a comma b plus 4 into x minus a into y minus b whole cube. Please remember, x powers are decreasing, y powers are increasing. That is the idea. In the binomial sequence that happens, right? F of x y cube a calculated a comma b plus the last term y minus b whole power 4 into f of y power 4 a calculated a comma b plus and so on and so forth. This is clear? Yes. So there are 5 terms. You can count the number of terms. 1, 2, 3, 4, 5. If you're talking about the next one, power 5 will have 60 terms. Okay, like that it continues. But okay, anyway, in the examination, as per the classroom exercise or the examination is considered maximum up to 3. If a rare case, we'll be asking for 4 together.